pen. My cliff. So what I'm going to do is draw my cliff as such. My horizontal velocity, I calculated at 37.588. So this is nothing new to us, right? My vertical velocity that it begins going up at was 13.681. Okay. Now what I did is I put my V2 up here, 0 meters per second. My A was negative 9.8 meters per second squared. Height and time, I just added those in. So if I wanted to approach this the way that you would have done it previous, I can do that. And so let's have a look at it. So let's find our distance above the ground. So my V1 is my vertical here, right? So I've got V2 squared. Actually, I'm just going to go straight to it. My distance is equal to V2 squared minus V1 squared over 2A. So I took 13.681 squared, divided it by 19.6. Okay, that's 2 times the acceleration of gravity. So I got a height of 9.549. Fair enough? So that's, no?
Yeah.
13.681 squared divided by 19.6. That's what I end up with. Then I calculated my time. So my time is equal to change of velocity over acceleration. So change of velocity is negative 13.68, and I divided by 9.8. And I got 1.396. Okay, so I haven't done anything new with this question. I just used the old stuff to start with. So how high above the ground is this actually then?
109.5.
Perfect. Okay. Now, again, I'm gonna get into the energy stuff in a minute. I just want to show you how you can approach this question without using any of the new stuff. So let's find out from the top down now. So I have 0 meters per second. My acceleration is 9.8 meters per second squared, right? My distance from the ground, you said, was 109.549 meters, right? So I could find out what V2 was, and I could find out my time. So calculate my V2. So that is going to be the velocity at which it hits the ground. Fair enough?
Yep.
Okay. So to calculate that, I got V1, A, and D. So I'm going to go V2 squared equals V1 squared plus 2AD. So I have the square root of, that's 0. So the square root of 2 times 9.8 times 109.549. So the square root of 2 times 9.8 times 109.549.
46.337 meters per second.
46.337. Okay, I had a different value there. Oh, sorry, no, I did not have a different value there, did I? Okay, yeah. So that's one more time, sorry, 46.3. Yeah.
37.
37.
Sorry, meters per second.
That's fine.
That's fine.
With things going on here, I'm looking at different answers. Okay, now that velocity right there is the combined velocity of the vertical and the horizontal. That's what it's hitting the ground at. That's not the vertical velocity that's hitting the ground at. All right?
That's like the final, right?
Yeah. So I'll get to that in a second here, but so this is what we ended up with by calculating the V2 when it hits the ground. Did I need to know that? I don't know. Yeah, I did.
Well, 'cause that's
Yeah,
the
so that would
C,
be-
right?
Yeah, so this is the C part.
They have,
The answer's different, and I did it different
Yeah.
when I got the answer.
I've got something different too,
I
so,
did it in different. I don't know,
hold
I
on,
did it
hold
in
on,
different-
just Chikai for a second.
Holy, everybody did everything.
Oh, I made an error here,
No.
I think. No, we shouldn't have. Okay, I've got 9.8, got 109.549. So why can't I calculate what the,
and that's how we did the other question, question
Yeah.
9.
it should still check. So, just a second, let me find out what I'm doing wrong here. Because I had something totally different. I got 59.666
Yeah.
or 67.
Oh, yeah, I
66.
round early, obviously.
Yeah. So 2 times 9.8 times 109.549.
And then you square it up.
Yeah,
It shouldn't matter which way you do it, it should work out.
it should be exactly the same.
But
So
did
what am I,
you
hold
use-
on, just a second, Austin.
All you have to do is like.
Just wait.
Meters per second and get it.
No, okay. That's the vertical velocity that's gonna hit the ground at. That is the actual vertical velocity. That does not include the horizontal velocity.
Right.
Okay? So, the other thing I wanna do is calculate time here. So that's, to calculate time, I have delta D equals V1 delta T plus 1/2 AT squared. So this is 0, right? So I take delta D, which is 109. I divide it by 4.9 and take the square root of it.
Can't we just do change velocity over A?
No, because you're using distance. You don't have velocity.
Then we just figured 46.
I don't, well,
You want-
yeah, it actually should give you the same answer. So if you took this and divided by 9.8, it would
Oh
give
my
you the same
goodness.
answer.
It doesn't.
It should.
What'd you get?
I get,
2 and 4.
you got what?
4.716.
Yeah, I got 728.
Yeah, that's what I
Yeah.
got. But I didn't do with your way.
And you got 2.364? Oh, great.
Thoroughly confused.
I
Okay.
used time and I got it right, so.
All right, let's go back just a second here. Okay.
This is ridiculous.
Okay, just chill out here. We'll get this to make this work. All right, what part are you confused on?
What? Okay, I did it completely differently, and I did it the
I-
same way that we did the other question.
Okay, but just, I'm not doing it yet. I'm not doing this question the way I want it done yet. I will do it that way in a second, in which I'll pick off A, B, C, D, and E. I'm showing you this so that our totals will match up. So now, I will start from what you did. I will do that now.
Okay, but
Okay, so this is still right though. My total time is this plus that. That is my total time. But I don't need the total time for this question at all. So here's how this is the way you're supposed to do this question. So I want to do it separate of these guys. So I'm going to do this again here. I'm going to put that in there. All right, so this is how the question should have been done. But my total should still work out. All right, so my kinetic energy, my potential energy, that's right here. That's the total energy. So total energy is equal to 1/2 10 40 squared plus 10 times 9.8 times 100.
Yeah.
And I got my total energy to equal 17,800. That's what I get. Everybody's okay with that? That's the start. So that answers A. What is its energy at the highest point? That's still the energy at its highest point. That doesn't change now. That's the same all the way through the arc. That's what your energy is going to be. What is the final kinetic energy? So the final kinetic energy, the potential energy is 0 at that point. So your final kinetic energy is going to be 17,800 joules. So that takes care of A and B. Okay, so far?
Yeah.
That's how we did it before.
Yeah, that's exactly how it happened.
All right. Now, C. What is the ball's final velocity? Okay. So I know that the final kinetic energy is this. So my final velocity, this is the catch in the question. I will explain it, or I will ask for it very specifically on the test. Right now I've left it open. The last velocity will be a combined velocity because I have 0 potential energy and I want to find out what this is here. So that is going to be the combined horizontal and vertical velocity. Follow?
Yep.
Okay, so now I get my V. So I take 17,800 divided by 5 and the square root of it, and I get 59.666. All right, now I'm gonna, are we okay up to this point, Amy?
Yeah.
All right,
I'm not.
you're not at this point?
No.
What's wrong?
Well, why? Because when we did the last time.
Just let me get to that now. I'm going to answer that right now. So now, if I'm using these formulas, Aaron, you want to see how I get that number right there? This is how I get that number. 17,800 equals the kinetic energy of the horizontal plus the kinetic energy of the vertical. 1/2. The horizontal speed of this guy was 37.588, right? Squared equal, plus 1/2 10 times V squared. Okay, so now what I want you to do is I want you to take 17,800 and I want you to subtract this. So 5 times 37.588 squared. It equals,
saying random numbers.
Yeah.
divide by 5.
Thought you were just saying
There's
random
5.
Yeah,
numbers.
hit equals
Yeah.
and square root
That's
that.
6. Minus 2.
What do you got?
Your number- Never mind. Yeah, it's 49.35.
49?
59.
0.197.
Is that right?
Still. No, I got 59.
Yeah.
For this?
Yes.
Yeah.
I did not.
I got 40.
Yeah,
Yeah, I got 46 too.
Hold
Oh,
on, you really need me to.
I got 36.
What is it?
46.337.
Because it'll be the same as your other one.
So what did I find right here? My vertical velocity. They are exactly the same.
So then, if you get your vertical velocity, in order to find your combined, put it back into that formula.
Actually, it's
right?
even easier than that. You could just use Pythagoras' theorem, to be honest with you, and it would work.
That's what I tried to do and I did it wrong.
Yeah.
Like I got the answer. using
But,
this,
let's not do that.
Okay.
Okay, so now, go ahead.
We're gonna have to explain why they're different.
Why they're different?
Yeah.
The energy that we found here was a combined energy. So there's a horizontal and a vertical, as well as the potential energy. So what this value indicates is the combined vertical and horizontal together. This one is just the vertical velocity. I have to subtract the horizontal kinetic energy from it in order to get that one. And that's how they end up being the same. Yes, Amy?
But you're using the horizontal velocity, like, so how is that only vertical?
I don't understand your question.
Never mind.
Did you answer it or no?
I think so.
Just because like the other question is a little different, but because you're at the bottom and there's no potential energy because it's all kinetic, that's why you say
Yes.
0.
Yes.
And
You got it?
yeah.
Does that make more sense now, girls?
Yeah.
Okay, so that's how your numbers are matching now in this question. That's why I wanted to go through this first, so that when I come to this point, it all magically equals each other. and you understand that how that ends up being
All
this.
the magic words.
So I can do that without time, is what my point was of the whole thing.
Yeah, but the 46 is in your answer though.
Okay.
What do you do?
So now, what's that, sorry?
No, he's showing you how you can get the answer you guys had.
Yes.
Yeah.
But
So by getting
59.7 is the answer. It's given to you because it's combined. Because I didn't specify I wanted the vertical velocity. I wanted a velocity at the bottom.
So technically.
All right. So it's right. It's all right. Every part of this.
So both
So what was
answers
it then?
Yes.
are specifically, okay.
Yeah, but I will be more specific on the test. I will say, what is the vertical velocity that it hits the ground at?
And that would be the 46.
And that's the 46.337. And you can get that using this or this.
Okay.
Okay? All right. And then it says, what height will the ball rise above the ground? Well, that's just that, 9.549. And what is the speed of the ball when it is 20 meters above the ground? So this again, when it's 20 meters above the ground. Now, can I show you using this first?
Sure.
Okay, so here's what I want you to do. On that part right here. So I'm going to use this same information here, my same starting point to get what that velocity is going to be. So I'm looking for a V2 now. So my V1, as the ball starts coming back down from its peak, is 0. My acceleration is 9.8. All right. How much distance is covered? Minus the 20. That's how, because I want to find out how far it fell.
89.548.
548 meters. All right.
280.
So again, so the square root then of 2 times 9.8 times 89.548.
41?
Yes, 894.
Yeah, I mean, per second.
So that's what I get there. And again, that's the vertical velocity that it's going to be coming to the ground. Brock, sit, man.
So that's question, that's the answer for question E.
So that is, yes, that's the answer for E. Now, go back to over here. Go back over to here. And let's do this again. The velocity is. So I go 1/2, 10 times 37.5. This is the same question. Squared plus 1/2, 10 times v squared. And now it's going to be plus 10 times 9.8 times 20. Okay, so this is your horizontal kinetic energy. This is your vertical kinetic energy. And this is your potential energy 20 meters above the ground. So I take this, subtract that, divide by 5, and then square root it. And I will end up with the exact same answer, which was 41.894.
You have to do both of them.
Go ahead.
You have to like add the 1/2 times 10.
I got to
that.
subtract this from this side, and I have to subtract that from this side. I mean, you could add them together and then subtract them.
Could you use your find combined speed instead of like? That's okay. So that's probably what I would.
And what are combined speed like be the 40?
The combined speed is just that then. The combined speed means you don't use the horizontal, you just use those two values.
Okay, yeah. You said the same thing?
No, you would get a different answer for the combined speed. All right, Amy, is that better? I did the same thing that we did before.
Yeah.